this says the function f has a derivative given by f prime equals this factored polynomial. At what value of x does f have a relative maximum? All right, so by the first derivative test, we're just going to summarize what we see here. Here's our function f prime, or here is f prime. Its zeros are -1, 0, and 3. And so if we evaluate at each of these, in these subintervals, we'll figure out whether f is increasing or decreasing. Here's a little trick, by the way. So we're going to pick let's pick a sample value in this range here, right? Like 4. So, we have 4 times 4 minus 3 squared times 4 plus 1. So those are all positive, right? A positive times a positive times a positive. So we get a positive, which means our function is increasing. Here's a little shortcut. We're not plugging 3 in, but anything else you plug in, this is going to be positive, right? Because you're squaring it. So that we can just ignore. Everything's determined by what happens with x and x plus 1. So if I plugged in 2, for example, I would get a positive, the middle is positive, and then 2 plus 1 is positive. Okay, so increasing here. Suppose I plugged in negative a half. Negative a half is negative. Negative a half minus 3 squared, we know is positive. Negative a half plus 1 is positive. Here I get a negative. Okay, another little trick, if you remember from pre-calculus, look, the multiplicity on these terms, those two terms is odd, and the multiplicity here is even. So that's why the graph bounced up here at 3. It's going to cross at -1 and 0, which we saw here. But there's a shortcut. It's going to cross and become positive again. Okay. Of course, you could also plug in, let me just kind of indicate that. Of course, you could also plug in a sample x value. Wait, I just flipped that. In any case, now we got our local maxes. So by the first derivative test, your function's creating a local max here. And that's it. There's a min here, and there's neither at 3. So at what values does x have a relative maximum? The answer is at -1, which is A.